This topic is about recognizing and describing transformations in x and y directions. We need to be able to write down the new equation after translations that have taken place. So let's go through all the graphs that you need to know, the standard graph curves that you might be asked to transform in an exam. So the first one is y is equal to x squared. So if you think about the graph, y is equal to x squared goes through the origin and it's a parabola. So U-shaped parabola. Okay, y is equal to x cubed is another one that you need to know. So because x cubed is positive, it's like a twist that goes through the origin. Something along this line, yeah? Okay, y is equal to 1 over x, which is the reciprocal graph. Okay, remember there's two parts, which is in the first quadrant and in the third quadrant. And remember, there are two asymptotes. X is equal to 0 and y is equal to 0, which will be translated after translation. So you need to move those asymptotes around according to what the translation is. Okay, y is equal to 1 over x squared. Because it's x squared, everything's going to be positive. So what happens is it's in the first quadrant and the second quadrant, because all the output will become positive. Okay, again, there's an asymptote, two asymptotes. So y is equal to 0 and x is equal to 0. Y is equal to 2 to the power of x. So the exponential graph, it doesn't have to be 2 to the power of x. It might be y is equal to a to the power of x, where a is greater than 1. So remember, it goes through 1. And so it goes through y is equal to 1. So our y-intercept is at 1. And also it has an asymptote at y is equal to 0. Okay, x to the power of 4. Just draw it slightly smaller. So x to the power of 4 is sort of like a quadratic graph, but it's just a bit wider. And I just need it in the same color. Okay. Y is equal to square root of x. Now when we do functions, we realize we talk about input and output or domain and range. But basically in this case, x has to be positive. So you only draw the positive part of the graph. So root x means positive root x, sorry. So it's only going to have a positive answer. So that is how y is equal to root x looks like. And the last one, which is y is equal to cube root of x. Again, this will be more clear when we do functions. But it looks like a bit like the cubic graph, but the opposite way around. So going through the origin still. Okay, so these are all the standard curves you might be asked to transform. The only other one that I can think of that you might want to think about is this extra one. X, y, which is equal to y is equal to log base 10 of x or log base a of x. Okay, remember the input always has to be positive. It goes through, it has an x-intercept at 1, and it has an asymptote at x equals 0. Okay, let's look at all the translations, different versions you can have. So you can obviously have translations for k greater than 0. So let's look at the cases where k is greater than 0. You can have translations in the y direction or translations in the x direction. Now, if you look at the translation in the y direction, which is this one and this one, you see the constant k is after the f of x, yeah? So I say it's outside the bracket, yeah? So f of x plus k. And f of x minus k is outside the bracket. The minus k is outside the bracket. So translation in the y direction, the k, the constant that we're moving it by or translating it by, is always outside the bracket. Okay, so let's look at what happens when we do these translations. So if we're looking at this is x and this is y is equal to x squared, looks like this. So y is a parabola going through 0. So y is equal to x squared. So this is the first one. Now, if we think about y is equal to x squared plus 3, then it's going to be, because we're adding 3, this origin, oops, undo. It'll go through 3 now, here, and everything will shift upwards by 3. So it's gone up by 3 from the original. That means if I were to write it out, it's a translation in the y direction. So if you think about it, it's moving vertically in the y direction by positive k. So if it's positive 3, if we're adding 3, it's going to move up by 3, by positive 3. So moving the y direction by positive 3. Another way of saying this, the same, is saying translation by the vector 0, k. So that's another way of saying this. Okay, let's look at the second case of translation in the y direction. So if we were to look at this one, so again, if I sketch it out, this is x, this is y. So the first one is y is equal to f of x, which is equal to x cubed. So x cubed, the twist going through like this. Y is equal to x cubed. Let's call this y. Y is equal to x cubed y is equal to x squared plus 3. Okay, so now I'm trying to do f of x minus 4. That's the same thing as x cubed minus 4. So if we go through the origin here, now it'll go through minus 4, because I'm doing 0 cubed minus 4. So it's going to go through minus 4, which means everything's going to shift downwards by 4. So it's going to look like so. Okay, so everything's going to shift down by 4. Okay, so if I were to write this out in words, it's a translation in the y direction by negative k. And in other words, it's translation by the vector 0 minus k, because it's gone down by k, so we're subtracting k from the y. So those are translations in the y direction. Okay, let's look at what happens when we're looking at translation in the x direction. If you look at the first case, do you see how it's inside? The k is inside the bracket. So when it's inside the bracket associated with the x, then it's in the x direction. Here again, the second example, you see is f of x minus k, close bracket. So that means it's inside the bracket, the x is affected. So it's translation in the x direction. Okay, so if I were to sketch these out, I'll just go here and do this. Y is equal to x squared, the first one, which is just a parabola again. Y is equal to x squared. Okay, second, the translation we're looking at is equal to y is equal to x plus 2 squared. So I didn't enable this one. Y is equal to f of x minus 4 for this one. Okay, so we've got y is equal to x plus 2 squared. If you look at that, if the bracket is equal to minus 2, you know it's going to be 0. So that means where it goes to the origin there, now it's going to go through minus 2 here. So do you see how, even though it's x plus 2 all squared, it's actually moved in the opposite direction. So you subtracted 2, even though, so you subtracted 2 here. So the opposite things happen when it's a translation in the x direction. So this is labeled as y is equal to x plus 2 squared. So if I were to write it out in words, it's a translation in the x direction. Now, even though it's f of brackets x plus k, it's by negative k, okay? So it's always opposite when it's the x that's being affected. So in other words, it's a translation by the vector minus k 0. Okay, and the last one, which is here, if I sketch it here, x and y, f of x is equal to x cubed. So this is the first one. It's x cubed with a twist. Oops. It's a rough sketch, so it's fine, even if it's not perfect. Y is equal to x cubed. Its second one is y is equal to f of x minus 5, which means it's x minus 5 all cubed. Now, if you think about this one, because it's x minus 5 all cubed, when x is 5, it's going to go through 0. It's going to be 5 minus 5 cubed is just 0. So that means at 5, it's going to go through the x-axis, okay? Which means even though it's x minus 5, it's actually moved in the positive x direction by 5. So the whole thing is going to move by 5 in the positive direction. So it's x direction, so like so. So which means, if I had to write it in words, it's translation in the x direction by positive k. So it's a translation by the vector k0. Okay, so if I were to split it up, so let's just do it in green, and then just so it's easier to read, those are all the separate parts that I've gone through. If I had to summarize, if the k is outside the bracket, it's a translation in the y direction. If k is inside the bracket, it's a translation in the x direction. And if it's translation in the y direction, if it says plus k, then the translation is plus k. But if it's translation in the x direction, it's the opposite. So if it says f of x plus k, it's going to be subtracting k. Let's do some examples and see how each one is affected by this. Okay, so sketch the graph of y is equal to root x and y is equal to root x minus 5. Okay, so if I think of y is equal to root x is the original, then y is equal to, y is equal to root of x minus 5. Because the minus 5 is inside is affecting the x, yeah? So it's a translation, because the original function is root of x, so it's not outside the bracket, it's inside the bracket. It's a translation in the x direction, which means the opposite things happen. The opposite thing will happen. So if it says minus 5, it's actually be translating the x direction by positive 5. If you want to say it in other words, it's translation by the vector 5, 0. Okay, so if I were to draw it out, y is equal to root x looks like this. Oops. Let's make this longer, maybe. This is y is equal to root x. Then it's a translation by the vector 5, 0. So everything moves in that positive x direction, positive by 5. So that means if I were to sketch y is equal to root x plus 5, it's going to go through 5 there, and this is y is equal to root x minus 5. Okay, so everything moves by positive 5. Okay, it doesn't have to be entirely accurate as long as it's clear what's happened. Okay. Let's go to the next example. Sketch the graph of y is equal to 1 over x and y is equal to 1 over x plus 2. Again, the original function is y is equal to 1 over x. So we're looking at y is equal to 1 over x plus 2. Again, the 1 over x, the reciprocal function is the original function. We added 2 to x, so it's the x that's being affected. So it's a translation in the x direction. And because it's a plus 2, obviously the x is being affected, which means we have to do the opposite. So translation in the x direction by negative 2. So in other words, translation by the vector minus 2, 0. Is this out now? So if I'm sketching this out, this is my x, this is my y. This is y is equal to 1 over x. Okay, again, my asymptote would be x equals 0 and y equals 0. So 1 over x plus 2 is a translation by the vector minus 2, 0. So now everything's going to shift. So in the negative 2 direction for x. So it's going to look like so, where my asymptote moves from x equals 0 to x equals negative 2 now. And then like so. And my other asymptote stays the same because it did not move in the y direction. So y is equal to 0 still. So the asymptote, it's very important that you label the asymptote here. Okay, the next example, the function f of x has a coordinate 2, 1, and 0, minus 3. What is the image of these coordinates after translations f of x plus 2 and f of x minus 3? Okay, so the first one is f of x plus 2 is a translation in the x, because inside the bracket is the x direction, by negative 2, because inside the bracket, if the x is being affected, it's always opposite, so by negative 2. So which means it's a translation by minus 2, 0. Therefore, 2, 1 under this transformation, under the transformation f of x plus 2, becomes 2 minus 2, which is 0, and the y stays the same because it's only the x that was affected. And 0 minus 3 under the transformation of f of x plus 2. Again, the x direction it goes down, the x coordinate goes down by 2, so it's going to be minus 2, y is unaffected, minus 3. In a similar way, if I do f of x take away 3, is a translation, because the minus 3 is outside the bracket, is a translation in the y direction. And when it's the y direction, it's the same sign, so by negative 3. Which means if I need to write as a column vector, it's a translation by 0, negative 3. So the x remains unchanged. The y coordinate, you just have to subtract by 3. So 2, 1 under the transformation f of x minus 3 becomes x stays the same. 1, the y coordinate 1 take away 3 gives me minus 2. So it's negative 2. And the other one, which is coordinate, which is 0, minus 3, under the transformation f of x minus 3, the x remains unchanged, and the negative 3, you have to subtract 3 again, which gives you negative 6. Okay, so describe the relationship of the graph y is equal to x squared and y is equal to x squared minus 4x plus 7. So if the original is y is equal to x squared, which is the more basic function, then what I need to do is I take the other function, which is a more complicated function, which is x squared minus 4x plus 7, and I need to somehow write it in terms of x squared. Now what I need to do is, at the moment, I've got this x coefficient, which makes it complicated to write as a transformation. So what I need to do now is complete the square. So always complete the square in these cases. So when I complete the square, I get x minus half of 4 is 2, all squared. I need to subtract the constant term that I get at the end, which is minus 4, and then there's a plus 7 at the end, so I get this case. If I simplify, I get y is equal to x minus 2 squared, minus 4 plus 7 is plus 3. And this is in the form that we want it. This is the same thing as if I call this y is equal to f of x, then this is the same thing as y is equal to f of x minus 2 plus 3. Because if the original function is x squared, all I've done is replace x with x minus 2, and then I've added a 3. So it's the same thing as f of x minus 2 plus 3, which is a translation by the vector. Because it's x minus 2, it's a translation in the x direction by the opposite number, which is positive 2. So translation by 2, and translation in the y direction by positive 3, because there's a plus 3 outside the bracket. So it's a translation by 2, 3. Okay, so if you want to write it in longer words, it's translation in the y direction by positive 2, translation in the x direction by positive 2, and translation in the y direction by positive 3. Which means if you think about it, it's like saying y equals x squared goes through the origin. I don't think that's a great graph, so let's draw it again. So this is y is equal to x squared, and your x squared minus 4x plus 7 is the same thing as having 2, 3 as your minimum point. So it has a minimum point at 2, 3, which means it is being translated in the x direction by positive 2. The origin has moved from the minimum point has moved from the origin to 2, 3. So it's moved in the x direction by positive 2 and moved in the y direction by positive 3. Okay, so in an exam, you sometimes have to describe transformations. So what I want to go through is, obviously there's a lot of errors in how students describe these translations. So I want to say which one of these are 9 different ways that your student describe these transformations, which ones are correct and which ones are not. Okay, translate the curve by positive 5 on the x-axis. Anywhere where you may mention the x-axis, straight away it's a cross. It doesn't work out because it's not just the x-axis that's moving, it's more than that, yeah? So this is wrong. So I would say no. Translate the curve by positive 4 parallel. As soon as you say parallel to the x-axis, then it's correct. So that is a correct way of saying it. Third option is translate the curve horizontally by positive 4. That would be a correct description, because horizontal, you're saying horizontally, yeah? So which is parallel to the x-axis. Translate the curve by positive 3 across the y-axis. Again, because you're saying across the y-axis, that would be incorrect. So don't say it in that way. You might possibly lose a mark in an exam. Okay, translate the curve by negative 10 in the y-axis. Again, no. Because if you're just doing in the y-axis, it does not make sense. Translate the curve by negative 2 in the y direction is correct. Translate the curve by negative 1 up the y-axis, I would say that is not correct. Translate the curve by positive 7 along the x-axis, again, no. The only word that is allowed is parallel, yeah? Parallel. And translate the curve by 0 minus 4, which is correct. So there's 5 of these statements that are correct. I would say note, do not use the words move or shift. Okay, and I would say that statement 9 is best. So translate the curve by this vector is the best way to say. Instead of talking about the x direction or the y direction, if you just say the vector, then it's easiest. Okay, sketch the following graphs. In each case, give the coordinate of the minimum point of the curve and the coordinates of any point where the graph meets the coordinate axis. Okay, so first one. Okay, y is equal to x squared. X, y. So y is equal to x squared is a parabola that goes to the origin. Y is equal to x squared, so you can just write the origin here. Okay, 2. Y is equal to x squared plus 2. Okay, if that y equals x squared is the original function, and x squared plus 2 is a translation in the y direction by positive 2, which means it's just the original graph, the first graph, translated up by 2. So now it will be something like this. Oops, undo. Need to make sure the vertex is on the y-axis. Something like this, and it goes. So this is y is equal to x squared plus 2, and it goes through the point 2. Okay, so as long as you mention that, that is enough. If you want to be a bit extra, so you can write 0, 0. You can write 0, 2 if you want. The next one is y is equal to x plus 2 squared. So this is translation. So translation by 0, 2. This is a translation. It's inside the bracket, so it's the x that's affected. So it's going to be the opposite, which is minus 2, 0. Translation by minus 2, 0. Okay, so if I were to sketch this, so number 3. Okay, so x and y is translated by minus 2, 0, so moves translates by minus 2 into x direction. So now it'll look something like this. Whoops, let's redraw that. It doesn't matter because it's not to scaling as long as you label it right. So this is going to be now minus 2, 0. Y is equal to x plus 2 squared. The only thing I need to do is label this point. This point is 0 plus 2 all squared, which is just 4. So it's going to be 0, 4. Okay, next one. This is x squared minus 1, so it's translation by 0 minus 1. It's outside the bracket, the y is affected, and the y coordinates decrease by 1, so subtract 1. So that means it's going to go down by 1, so we're going to end up with something that looks like this. This point is 0 minus 1. To find these points, same thing as equating x squared minus 1 to 0, which means x is equal to plus or minus 1. So that means 1, 0, and minus 1, 0. Okay, fifth one is a translation by, it's inside the bracket, so x is affected, so it means it's going to be positive 1, 0. So everything is going to shift to the right by 1. So it's okay to use it in my obviously explanation, but don't write shift in exam. X and y, so now it'll be there where this is 1, 0. I just need to find this point. I didn't label this graph. X squared take away 1. This is y is equal to x minus 1 squared. To find this point is 0 minus 1 all squared, which is 1. So this is 0, 1. Okay, and the last one is a translation This is in both the x and y direction. So translation by +2 in the x and +1 in the y. So if I were to draw this one out, x, y, that means +2 in the x direction 1, so it's going to look somewhere like this, somewhere like there. The vertex is going to be somewhere at 2, 1. So this is the vertex at 2, 1. Just label that, even though, oh, he did say coordinate minimum point. So I've labeled the minimum point everywhere already. Yep, that's fine. Now, to find this point, all I'm doing is substituting x equals 0 in. So I get 0 minus 2 all squared, which is 4. 4 plus 1 is 5. So that is 0, 5. So this is y is equal to x minus 2 all squared plus 1. Okay. Next example. Okay, the diagram shows the graph y is equal to f of x, which has a maximum point at 0, 1. Okay, let's call that 0, 1, yeah? Describe the transformation in words. Sketch the following graphs, giving the coordinate of the maximum point in each case. Okay, so 1 is f of x minus 2 is the x being affected. So this is a translation by, because the x is being affected, it's the opposite constant. So it's going to be 2, 0. So which means if I were to sketch this out, translation by 2, 0, which means, 2, 0 means that the point 0, 1 will become 2, 1. So everything has shifted here. So, don't know. So this point is 2, 1 now. Okay, second one is f of x plus 3. So it's a translation by, again, x is being affected, so it's the opposite, minus 3, and y is unaffected, so minus 3, 0. Which means it's going to move to the left by 3. So if I were to sketch this one out, this is x, and this is y, then it's shifted by minus 3. So this is minus 3, 1. Okay, so number 3 is y is equal to f of x plus 1, because 1 is outside the bracket, it's translation in the y direction. And because it's translation in the y direction, it's going to be the same number. So it's 0, 1. Okay, translation by 0, 1, which means it's going to go up by 1. So if I were to sketch this one out, is x, and this is y, then everything's going to move up by 1. So this point, maximum point, is at 0, 2, and also there's an asymptote at y equals 1. So the asymptote for this one was y equals 0. Y equals 0. Okay, next one, which is for question 4, is f of x minus 2. F of x minus 2, translation by, again, it's the y affected because outside the bracket, so it's 0 minus 2, the number stays the same. So if we had to sketch this, x and y, so the point with the maximum point was 0, 1. So if you subtract, if it goes down by 2, it's now at 0 minus 1. So this point is at 0 minus 1 because it's gone down by 2. And that also means there's an asymptote at y equals minus 2. Okay, the last one, which is 5, f of x plus 1 take away 3 is a translation in both the x and the y direction. So translation by minus 1 in the x direction, because it does the opposite thing, and minus 3 in the y direction. So if we were to draw it out, this is y, this is x. So the maximum point was at 1, 0. So if I subtract, so 0, 1, if I subtract 1, it'll be minus 1. And then if I subtract 3, it'd be minus 2. So at minus 1, minus 2, you have the maximum point. And then it looks like so, which means the asymptote is at y is equal to negative 3. Okay, next example. The diagram shows the graph of y is equal to f of x and the lines x equals minus 3 and y equals 5, which are asymptotes. Sketch the following curves, and each case sketch and label the asymptotes. Okay, so y is equal to f of x plus 3. It's a translation in the y direction. So translation by 0, 3. So everything moves down. Sorry, moves up by 3. Okay, so because it's translation in the y direction, everything moves up by 3. So if I do it on the same one, okay, y equals 5. The asymptote is no longer y equals 5. It's now y is equal to 8. So if I were to draw it, actually I might have to draw it in a separate one. Let me just draw it underneath it. X and y. So now the asymptote will be at y equals 8. Y equals 8. The x equals negative 3 is still an asymptote because it has not moved in the x direction. X is equal to negative 3. Okay, so this part of the graph will still be the same. And because everything has moved up by 3, it might just intersect it. It doesn't matter as long as it doesn't cross the asymptotes. And here, again, everything has moved up by 3. So it still looks similar like this. Okay. Next one. Describe fully the transformation that maps graph of y equals f of x onto the graph y is equal to f of x plus 1. It's a translation in the x direction by negative 1. Or if you want to say, it's a translation by minus 1, 0. I'm not quite happy. So translation in the negative x direction by unit 1. Okay, B is sketch the graph of y is equal to 1 over x plus 1. So if I were to sketch it, showing the coordinates of any points of intersection with the coordinate axes and the equations of any asymptotes. So y is equal to 1 over x plus 1 is the reciprocal function translated in the x direction by a negative 1. So that means reciprocal function shifted in the negative x direction by unit 1. So it's going to look something like this. So x is equal to negative 1 and something like so. The y asymptote, so the horizontal asymptote has not changed, so it's y is equal to 0. The only thing I need to find is label any points of intersection is find this point. That means that is obviously 1 over 0 plus 1, which is just 1. So that point is 0, 1. And there are no other intercepts. Should have been a -1. X is equal to -1. C is by sketching another suitable curve on your diagram in part B, show that the equation x cubed minus 1 over x plus 1 is equal to 2 has one positive and one negative root. Okay, so I've got x cubed minus 1 over x plus 1 is equal to 2. Let's label this as y is equal to 1 over x plus 1. So I need to make 1 over x plus 1 the subject of this formula. So x cubed is equal to 2 plus 1 over x plus 1. So that means 1 over x plus 1 is equal to x cubed minus 2. So now I need to sketch the graph of x cubed minus 2. So x cubed minus 2, x cubed minus 2. F of x is equal to x cubed minus 2 is f of x is equal to x cubed translated by 0 minus 2. So it's the cubic root, which is a twist. And let me just use a different color, and it's been shifted down, so moved down by 2. So it's going to go through my 0 minus 2, and then it's a cubic graph, so it's like a twist. And you can see clearly there's two intersections. Okay, this intersection is a root which is negative, because you can read off that's negative, and this is a root which is positive. Okay, so if I were to explain it, f of x is equal to x cubed minus 2, and f of x is equal to 1 over x plus 1 intersect at 2 points. Therefore, both two roots, they intersect with one root positive, you can see clearly from the graph, and one root negative. And that's it. Last question, what is the new equation? So f of x is equal to x cubed, translate 5 units in the positive y direction. So that means it's outside the bracket, it's y direction, so f of x is equal to, take the original function, which is x cubed, and then just add 5. That's already simplified, so we don't need to do anything. Okay, next one is f of x is equal to 1 of x squared. Translate 3 units in the positive x direction. So that means, maybe I should rewrite it as f of x plus 5 is equal to x cubed plus 5. So if f of x is equal to 1 over x squared, translate 3 units in the positive x direction. The same thing as, I've done it wrong, let's try again. Okay, translate 5 units in the positive direction, in the positive y direction means it's f of x plus 5, yeah? It's like that because outside the bracket, which means it's x cubed plus 5, okay? Let's use the correct notation. F of x is equal to 1 over x squared. Translate 3 units in the positive x direction. So that means it's f of x minus 3, because obviously if it's positive 3 in the x direction, it must be f of x minus 3, which means I've got 1 over x minus 3 all squared. Now we can expand the bracket, but in this case, it's better to leave it in this form. Okay, translate. Next one, f of x is equal to x plus 2 times x minus 1. Translate 3 units in the negative x direction. That means it's the same thing as f of x plus 3, which means everywhere we see x, we replace with x plus 3. So it's going to be the same thing as x plus 3 plus 2 in the first bracket, and x plus 3 take away 1 in the second bracket, which is the same thing as x plus 5 times x plus 2. Okay, the next one is f of x is equal to x times x minus 1 times x plus 6. Translate 1 unit in the negative x direction. So that means it's f of x plus 1. And 2 units in the negative y direction. So subtract 2 outside the bracket because that's affecting the y coordinate. So everywhere we see an x, replace with x plus 1. So the first term becomes x plus 1. Second term becomes x plus 1, take away 1. And the third term becomes x plus 1 plus 6. And then we need to take away 2 at the end. If I simplify this, the second bracket becomes x. The first bracket is x plus 1. And the third bracket is x plus 7. Take away 2. Now we won't expand and simplify, we'll just leave it in this form. Okay, next one. Describe the transformation. Describe the transformation. So y equals x cubed to y equals x minus 1 cubed, take away 4. So translate y equals x cubed by the column vector. X is a translation in the negative x. Sorry, it's x minus 1 cubed. So that means it's in the positive x direction by 1. And negative 4 outside the bracket. So in the y direction by negative 4. Okay, y equals x squared to y equals x squared plus 4x minus 5. If I complete the square, I get y is equal to x plus 2 all squared, take away 4, take away 1, which is equal to y is equal to x plus 2 squared, take away 5, which means it's a translate y equal x squared by, because it's x plus 2 all squared, you do the opposite, which is minus 2, and then there's a minus 5 at the end, so that means minus 5. Y is equal to root x plus 4 to y is equal to root x plus 1, take away 5. So if I take the original, if I take root x plus 1, take away 5, this can be rewritten as root of x plus 1 plus 4. I need to take away 5 for this. So what do I need to do to plus 4 to take away 5? It must be, I need to take off 9. Okay, which means this is a translation. So translate y equals root x plus 4 by, because underneath the square root you got a plus 1, that means the x coordinate for the column vector is minus 1, because it's the opposite. And then because from plus y to subtract 9 to get to 5, that must be minus 9 in the y coordinate for the column vector. So that is it.